Hello students, in this video we will see the chemistry practical for 12th standard. Before starting the video, please subscribe, like and share the video to get notification of the next video. The links for the other videos are provided below in the description box and also at the end of this video. Let us see aim of the experiment. To determine the concentration in terms of molarity of KMnO4 solution by titrating it against standard solution of oxalic acid. Theory: the substance available in the state of high purity are used to prepare standard solutions by dissolving a fixed or definite mass in definite volume of distilled water. Oxalic acid is primary standard substance. Its molar mass is 126 gram per ml. Apparatus: burette stand, burette, volumetric flask, conical flask, funnel and beaker. Chemicals required are oxalic acid, KMnO4 and 2 molar H2SO4. Step A: preparation of standard solution of 0.05 molar oxalic acid. Calculation: molar mass of oxalic acid is 126 gram per mole. For 1000 ml 1 molar oxalic acid solution, required mass is 126 gram of oxalic acid. Hence, for 100 ml 0.1 molar oxalic acid, the required mass is 126 into 100 into 0.1 divided by 1000 into 1. Answer is 0.63 gram of oxalic acid. Weigh accurately 0.63 gram of oxalic acid and then transfer it in a beaker. Wash the watch glass with distilled water, collect all the washings and then stir it well. Now transfer this solution in 100 ml volumetric flask and dilute it up to the mark by using distilled water. Then transfer the diluted solution in a beaker so as to get homogeneous solution. So this is 0.05 molar oxalic acid solution. Step B is determination of molarity of KMnO4 solution using standard solution of oxalic acid. Now fill burette number 1 with 0.05 molar oxalic acid solution and then burette number 2 with 0.05 molar KMnO4 solution. Now take 10 ml 0.05 molar oxalic acid solution in a conical flask. To this add 1 test tube 2 molar H2SO4 and then heat the solution to about 60 to 70 degrees centigrade. Thereafter titrate this solution with 0.05 molar KMnO4 solution. Continue the titration and stir the conical flask continuously till faint pink color appear to the solution. So this is pilot reading. In a similar way, find out the CBR for this titration. Observations: solution in a burette number 1 oxalic acid, solution in a burette number 2 KMnO4. Indicator is KMnO4 itself, end point colorless to pink. Write all the reading in observation table. Chemical equation: 2 KMnO4 plus 5 H2C2O4 plus 3 H2SO4 gives K2SO4 plus 2 MnSO4 plus 8 H2O plus 10 CO2. So from this equation, 2 into 158 gram corresponds to 1000 ml 5 molar KMnO4 equal to 158 gram per mole. So 1000 ml 5 molar oxalic acid equal to 316 gram of KMnO4. Therefore 100 ml 0.05 molar oxalic acid equal to 316 into 10 into 0.05 divided by 1000 into 5. Answer is 0.0316 gram. For example, CBR is 8.4 ml. Then 8.4 ml of KMnO4 solution contains 0.0316 gram of KMnO4 shown by the following calculation. That is 1000 ml KMnO4 contains 0.0316 multiplied by 1000 divided by 8.4 into 158 equal to 0.0316 gram. So 1000 ml KMnO4 solution contains 31.6 divided by 1327.2, which is equal to 0.02380. Now enter the result as the molarity of KMnO4 solution is 0.02380 molar. Students, thank you for watching this video. Please subscribe the video.